at this exact moment. While you are sitting here watching this video, there is a world beneath you, not far away, not on another planet, directly beneath your feet, beneath the ground, beneath the bedrock, beneath miles of ocean floor. A world that has existed for longer than complex life has walked on land. A world where the rules of survival are completely different, where beauty is a weapon, where light means danger, where creatures have evolved features so alien, so disturbing, so perfectly designed for their environment that scientists who study them full-time still lose sleep, thinking about what else might be down there that we have not found yet. We have sent humans to the moon 6 times. We have landed rovers on Mars. We have photographed black holes billions of light years away, and yet we have explored less than 5% of our own ocean. Less than 5%. The rest? Unknown, unmapped, unseen. What lives in that 95% we genuinely do not know, and the part we have seen? It is stranger than anything you have imagined. Stay with me, because by the time this video ends, the ocean will never look the same to you again. When most people picture the ocean, they picture the surface. Waves, sunlight, coral reefs, dolphins. That version of the ocean is real, but it is also in the grand scale of things barely a skin, a thin sunlit layer sitting on top of something vast, dark, and largely unknown. The ocean covers 71% of our planet's surface. Its average depth is 3,688 meters. At its deepest point, the Challenger Deep in the Mariana Trench, it drops to nearly 11 kilometers below sea level. 11 kilometers. If you placed Mount Everest at the bottom of the Challenger Deep, its peak would still be more than 2 kilometers underwater. Now imagine sinking, not swimming, not falling, sinking, slowly, deliberately. At the surface, warmth, light, life is loud here. Busy, colorful. You pass 10 meters, 20, 50. The water cools, the light begins filtering. At 100 meters, you are in what scientists call the mesopelagic zone, the twilight zone. Sunlight still reaches here just barely, just enough to cast shapes in dim blue. At 200 meters, something final happens. The last photon of usable sunlight disappears, not gradually, not slowly, just gone. Below 200 meters, there is no dawn, no dusk, no afternoon, no morning, no day. There is only the dark, and the dark here is not like the dark in your bedroom at night. It is not like a power outage. This darkness has weight. It has pressure. It has, and I want you to really sit with this word, presence. You are now in the bathypelagic zone, the midnight zone, and something is waiting for you here. Here is the question that confused marine biologists for generations. If the deep ocean is completely dark, if there is no sunlight, no moonlight, no starlight, why do so many creatures glow? Think about it. Darkness should mean invisibility, right? If nobody can see you, you are safe. You cannot be hunted if a predator cannot find you. So why, in the darkest place on earth, would a living creature produce its own light? Why advertise yourself in a place where being seen could get you eaten? The answer is one of the most complex, most layered, most surprisingly sophisticated stories in all of biology. And it starts with a chemical reaction. Bioluminescence. The word comes from the Latin to shine with life, but what it actually is, at the molecular level, is a controlled chemical reaction that produces light without producing heat. Inside specialized cells called photophores, a molecule called luciferin reacts with oxygen. An enzyme called luciferase controls the speed and timing of that reaction. The result, a cold, clean, precisely controlled emission of light. No heat wasted. No energy lost. In a place where every single calorie is precious, where food might come once a week or once a month, this efficiency is not a luxury. It is survival. And scientists have calculated something remarkable. Bioluminescence has evolved independently not once, not twice, but at least 40 to 50 separate times across different lineages of marine life. 40 to 50 separate evolutionary solutions to the same problem. Evolution kept arriving at the same answer, which tells you something important. Light even in darkness works. Down here, light is not decoration, it is communication. And the vocabulary is more complex than most people realize. Take the firefly squid Watasinia scintillans found in the deep waters off Japan. Its entire body is covered in photophores. Thousands of individual light-producing cells, each capable of firing independently. When a firefly squid communicates with another of its species, it produces sequences of flashes, patterns that scientists believe carry specific information. Not random blinking, patterns, codes. A language of light, written in fractions of a second, transmitted through water, received by eyes that have evolved specifically to read it. We do not fully understand what they are saying. We cannot decode it yet, but the structure is there. Then there is counter-illumination, one of the most elegant camouflage systems in nature. Many deep-sea fish and squid produce light from their undersides, and that light precisely matches the faint blue glow from the surface far above. From below, looking up, they are invisible, their silhouette the most obvious sign that something is there erased. Camouflage made of light in a world without sunlight. Think about the engineering of that. A creature, over millions of years, has calibrated the brightness of its own body to match ambient light conditions that vary by depth, time, and season. No computer designed this. No engineer calculated it. Evolution did. But here is the part that changed everything. Here is the discovery that made marine biologists completely rethink what they understood. Red light disappears from the ocean at very shallow depths, usually around 20 to 30 meters. Below that, red wavelengths are completely absorbed by water. Anything red in the deep sea appears completely black, invisible, which is why so many deep-sea shrimp, crabs, and fish are bright red. Not because red is beautiful, but because in deep water, red is the perfect camouflage. Be the most visible color in sunlight to become invisible in darkness. But then, in 2019, researchers from the Monterey Bay Aquarium Research Institute discovered something that shook the field. Some deep-sea predators can produce red bioluminescence, and some of their prey that thought they were perfectly camouflaged can see it. This means there is a private visual channel operating in the deep ocean. A wavelength of light that only certain predators and prey can see. An entire dimension of vision completely invisible to us and to most other creatures. The dragonfish hunts in this channel. It illuminates prey with red light that the prey cannot detect. The prey does not know it is being watched. It is already lit up, already seen, and it does not know. How many other private channels are there? How many other sensory worlds exist in those depths that we have not discovered? We genuinely do not know. Now, let me introduce you to something that has lived in the deep ocean for approximately 130 million years, something that survived the asteroid that killed the dinosaurs, something that has had 130 million years to perfect a single devastating strategy. It is not fast. It is not large. Most species are smaller than your fist. It is not particularly strong, but it has evolved the most effective trap in the history of the ocean. It is called the anglerfish. And the first thing you see, the only thing you see, in the dark is its lure, a thin, modified spine, extended from its forehead, tipped with a small organ called the esca, and that esca glows, a soft, cold, steady pulse of light. In absolute darkness, it appears from nowhere, a single small star, suspended in nothing. Small fish, crustaceans, anything small enough to fit in the anglerfish's mouth, they see that light, and they move toward it. This is not stupidity, this is biology. In the deep sea, light sometimes means food, bioluminescent plankton, things you eat. So moving toward a light source is a reasonable, evolved response. It has kept small creatures alive for millions of years, except now, they swim toward the light. They get close, and then they see the teeth. The anglerfish has a jaw that can open wide enough to swallow prey twice its own size. Its stomach is expandable, elastic, capable of stretching to accommodate whatever it catches. Its teeth curve inward, so anything that enters cannot back out. And by the time the prey realizes what the light actually was, it is already inside. But here is where the anglerfish story gets truly disturbing. The anglerfish we have been describing is a female. Males of certain anglerfish species are almost unrecognizable as fish. They are tiny, sometimes less than a centimeter long. They have no lure, no elaborate teeth, no developed digestive system. They have one purpose, one singular biological purpose: find a female. When a male finds a female in the vast, lightless, empty deep ocean, which is itself a nearly impossible task, he bites her. He bites into her skin, and then something happens that has no equivalent anywhere else in the animal kingdom. His body begins to fuse with hers. His skin merges with her skin. His bloodstream connects to her bloodstream. His organs, his eyes, his liver, his digestive system begin to degenerate. They dissolve. He loses everything that made him an individual organism. He becomes, functionally, a reproductive appendage, permanently attached, permanently dependent. In some cases, a single female has been found with 6 or more males fused to her body simultaneously. The deep sea did not create this because it is cruel. It created this because encounters in that environment are so rare, so improbable, that when one happens you cannot afford to lose it. Evolution eliminates waste, and in the deep ocean, individuality for the male anglerfish is waste. Let us talk about pressure, because everything in the deep sea, every adaptation, every body shape, every behavioral strategy is filtered through one constant, unavoidable, crushing reality. At sea level, the atmosphere pushes down on you with about 14.7 pounds of force per square inch. You do not feel it. Your body was built for it. At 100 meters of ocean depth, that pressure is 10 times higher. At 1,000 meters, 100 times. At 4,000 meters, 400 times. At the bottom of the Mariana Trench, over 1,000 times the pressure you feel right now. To put that in physical terms, the pressure at the bottom of the Challenger Deep is equivalent to having 50 jumbo jets stacked on top of you. A human body, unprotected, would not simply be crushed. It would be compacted, reduced, in seconds. So how do creatures survive there? The answer begins with one insight. Most damage pressure causes comes from pressure differences, gas-filled spaces, air pockets, cavities. Deep-sea fish have solved this by eliminating gas-filled spaces entirely. Many have no swim bladder, the organ most fish use to control buoyancy. Their bodies are filled instead with water-like fluids at the same pressure as the surrounding ocean. There is no differential, no boundary, no collapse point. They are, in a sense, already the same as the water around them. Their muscles are soft, gelatinous. Their bones, where they have them, are thin, lightweight, flexible. Speed is meaningless here. Power is unnecessary, so the body eliminates both. A deep-sea fish moving through the abyss moves slowly, deliberately, conserving every fraction of energy. Some species live for decades, growing only millimeters each year, their entire life unfolding in near stillness, in silence so complete, it is difficult for us to imagine. In the deep ocean, food does not swim to you, it falls. From far above, from the productive sunlit surface where photosynthesis happens, the remains drift downward. Dead plankton, fragments of algae, fish scales, shed exoskeletons, pieces of the world above, slowly sinking through thousands of meters of dark water. Scientists call it marine snow, and in the abyss, it is everything. By the time it reaches the deepest parts of the ocean, it has been traveling for weeks, sinking at centimeters per hour through water so cold and so still that nothing decays quickly. A delivery system thousands of meters tall, operating continuously for hundreds of millions of years, and entire ecosystems have organized themselves around catching it. Sea cucumbers drift slowly across the ocean floor, filtering marine snow from the sediment. Giant isopods, armored crustaceans that look like something from a nightmare, scavenge whatever falls. And then, there are the whale falls. When a whale dies in any part of the ocean, its body sinks to the bottom. And what happens next is one of the most extraordinary ecological events in the natural world. A whale carcass creates an entire ecosystem. First, mobile scavengers arrive within hours. Sharks, hagfish organisms that detect chemical traces of decomposition from kilometers away. They strip the carcass of soft tissue. Over months, the bones themselves become habitat. Specialized bacteria colonize the lipid-rich skeleton, producing hydrogen sulfide as a byproduct. And then organisms that normally live only at hydrothermal vents appear. Tubeworms, clams, mussels, species that were never expected to be found here. Somehow they found the whale. A single whale can support a thriving community of organisms for over a century. One death, sustaining life for 100 years. The deep ocean wastes nothing. Evolution, when faced with the problem of seeing in near total darkness, did not arrive at one solution. It arrived at dozens. The giant squid has the largest eyes of any living animal, up to 27 centimeters in diameter, about the size of a dinner plate. Those eyes evolved not to see detail but to detect the faint bioluminescent flashes produced by sperm whales as they hunt. The squid sees the whale coming before it arrives, a bioluminescent warning system, one glow in the dark telling the giant squid it is time to run. Then there is the barrel-eye fish Macropina microstoma. Its head is entirely transparent, a dome of clear fluid sitting on top of its face. Inside that dome, two glowing green tubular eyes, pointing directly upward, not forward, upward, always scanning the faint light above for the silhouette of prey. And then the creature moves, and the eyes rotate, forward, to look at what is directly in front of it. A fish that can swivel its eyes from vertical to horizontal, inside a transparent skull, in order to transition between spotting prey and catching it. Nothing in the sunlit world has an equivalent, but perhaps the most haunting adaptation of all is simpler. Many deep-sea creatures have lost their eyes entirely, not atrophied, not reduced, gone. Because in absolute darkness, eyes cost energy to grow and maintain, and they provide zero benefit, so evolution removed them. These creatures navigate through other senses, pressure waves in the water, chemical gradients, electrical fields generated by the muscles of nearby organisms. They perceive a world we cannot imagine, and here is the question I cannot stop thinking about. What does that world feel like from the inside? What is it like to be a creature that has never experienced light, not in its lifetime, not in its evolutionary history, and yet navigates, hunts, reproduces, survives? Is there experience there? Awareness? We do not know. We may never know. In 1977, a submersible called Alvin descended to the Galapagos Rift, a section of the Pacific Ocean floor where tectonic plates are slowly spreading apart. The researchers on board expected to find barren rock, cold, still, empty. Instead, they found life. Enormous fields of tube worms, up to 2 meters tall, swaying in the current, clams the size of dinner plates, shrimp, crabs, fish, all clustered around vents in the ocean floor, where superheated water as hot as 400 degrees Celsius was erupting from the Earth's interior. This discovery did not just add a new ecosystem to the list, it completely rewrote the rules of life. Until that moment, science operated on one fundamental assumption: all life on Earth ultimately depends on sunlight. Plants use sunlight to photosynthesize. Animals eat plants. Predators eat those animals. At the base of every food chain, sunlight. The vents broke that assumption completely. The organisms at hydrothermal vents use a process called chemosynthesis. Instead of sunlight, they harvest energy from chemical reactions. Bacteria oxidize hydrogen sulfide, the chemical that makes rotten eggs smell, and use the released energy to produce organic compounds. Tube worms, clams, mussels, they host these bacteria inside their own bodies. They have replaced the sun with chemistry. Life without photosynthesis, life without sunlight, life in a place where before 1977, we were certain nothing could exist. And this discovery opened a question that is now discussed in the halls of NASA. If life can exist at the bottom of our ocean in complete darkness, under crushing pressure, fueled by chemistry alone, what does that say about life elsewhere? Europa, a moon of Jupiter. Beneath its icy surface, a liquid water ocean, possibly with hydrothermal vents. Enceladus, a moon of Saturn, active geysers of water vapor erupting from its south pole, confirmed organic molecules in those geysers. If life does not need sunlight, if life needs only liquid water and a chemical energy source, then the universe becomes a very different place. Suddenly life is not rare. Suddenly life is almost inevitable. The deep sea did not just change biology, it changed our understanding of what is possible. Every year, deep-sea expeditions return with creatures that have never been seen before, species new to science, body plans that violate existing categories. In 2020, researchers discovered a siphonophore, a colonial organism composed of thousands of individual creatures acting as a single body off the coast of Australia. It was 47 meters long, longer than a blue whale, the longest organism ever recorded, and it had never been seen before. In 2021, a new species of fish was discovered in the Atacama Trench, the snailfish Pseudoleparus swirei, living at 8,336 meters below sea level. The deepest living fish ever recorded, completely transparent, gelatinous, ghost-like, thriving where nothing should thrive. And then there are the things we have captured on camera and cannot explain. Flashes of bioluminescence from objects too large to be any known species. Shapes that appear briefly at the edge of ROV lighting and disappear. Sonar readings of massive objects that do not match any identified species. Scientists are careful about these. They do not rush to claim monsters, but they also do not dismiss what the data shows. Because the history of deep-sea exploration is a history of being repeatedly, fundamentally wrong about what is down there. Every assumption we made, it cannot be that deep. Nothing can survive that pressure. Life requires sunlight. These temperatures are too extreme. Every single assumption has been proven wrong. What makes a good scientist is not certainty. It is comfort with not knowing. And the deep ocean is the ultimate teacher of that lesson. We rise now. Back through the abyss. Back through the midnight zone. The darkness loosens. Slowly shapes begin to resolve out of nothing. A faint blue-gray enters the water. Then blue. Then lighter blue. Colors that do not exist in the deep appear again one by one like memories returning. Below us now, the glowing continues. It never stopped. The anglerfish drifts slowly. lure pulsing. The dragonfish hunts in red light that nothing else can see. The 47-meter siphonophore drifts through black water. The vent fields pulse with heat and chemistry and organisms that have never needed the sun and never will. We like to think we know our world. We have named its continents, mapped its mountains, charted its rivers. We have looked at the surface of Mars in higher resolution than most of our own ocean floor. And somehow, in all of that, we forgot to look down. The deep ocean is the last great wilderness. Not the Amazon, not Antarctica, the deep ocean. A place where evolution has had hundreds of millions of years to experiment without interruption. A place where life solved problems we have not even identified yet. A place that holds somewhere in its cold, dark water answers to questions we have not yet thought to ask. We are surface creatures. We live in a thin, bright layer at the top of a deep, dark world. And somewhere below us something is glowing. Not for us. Not because of us. Because life, even in its most extreme form, refuses to stop. If you made it this far, you are exactly the kind of person this channel exists for. Not someone who wants to scroll past things. Someone who wants to actually understand the world. There is something I find genuinely moving about the deep ocean. Not because it is scary, although it is. Not because it is alien, although it is. But because it proves something. Life does not ask for permission. It does not wait for perfect conditions. It does not require sunlight, or warmth, or safety. It finds a way. Every time. In every corner of this planet we look, life is already there. Already adapted. Already thriving. Already ancient. And most of it we have not even seen yet. That is the kind of world we live in. And there are more stories exactly like this one waiting. If that interests you, you already know what to do. Subscribe, and I will see you in the next one.